Okay, so good afternoon, everyone. So, as per our previous exercise, we have done that we have given some of the questions regarding the modulation and analog modulation, digital modulation technique. And then after I have asked the one question is also there, like why digital signal is not preferred in a limitless channel, okay, a limitless channel based bandwidth. So, does anybody will open their mic and tell me that what is the answer of the third question? Why the digital signal is not preferred to send in a limitless channel? Anybody of from this class can open their mic and give me the simple answer that why we are not prefer digital signal to send directly in a limitless channel instead of we are preferring some of the modulation technique always. Why is it so? डिजिटल सिग्नल को हम डायरेक्टली चैनल पे नहीं भेज सकते, उसको मॉड्यूलेशन करना ही पड़ता है. Why? Can anybody give me the answer on this one? Please don't be shy. Open your mic and tell me. If it is right, wrong, doesn't matter. Those who have already written, they can at least give the answer. They have sent me the files. Those who are present in the last lecture, sorry. Yes, Anand Raichura. Can you give the answer, Anand? Darshan, Harsh Maheshwari, Fenil Rabadia. Please open your mic and tell me what is your thought in this one. Hello, Michal Parmar. Can you tell me? Mahfuz Alam. Somebody please open your mic and tell me.
Sir, I have just joined, so I don't know what is the question.
So question is that why in communication, during the communication, why the digital signal not directly sent to the channel, it will must pass through the any modulation technique. Why we cannot send directly the digital signal into the limited channel, limited bandwidth channel? Why is it so? What is the reason for that? हम क्यों वो डिजिटल सिग्नल को डायरेक्टली चैनल में नहीं भेजते, हम मॉड्यूलेशन उसको करते हैं? Why modulation is required in terms of digital signal? डिजिटल सिग्नल को ASK, FSK, PSK ऐसे मॉड्यूलेशन टेक्निक क्यों यूज करें? डायरेक्टली डिजिटल सिग्नल चैनल पे नहीं भेज सकते हम? This is my question. Please reply anyone from entire class. Nobody is responding. And how we can go with that? Like this is the end, like near to the end of the semester. If still you are not capable to give the answer, then in Viva what I consider? 0, 0, 0 to everyone? Tell me. In Viva, if you will not speak about the answer, then I will consider 0. Okay, frankly. I'm saying frankly, like you will get a 0 mark in Viva. How it is going to possible? Like everybody will get the 0 mark. Nobody speaking to simple question. Okay. If nobody is replying, let me give the answer because it's my duty. I need to give the answer. Other students are not. I don't know why so much kind of the laziness are there. Like not a single person will dare to open their mic and give the right or wrong, whatever the answer they know. I don't know. You have already some people has already written this answer in this question. Still, they are not ready to give.
So,
Yes, Mehbooz, boliye.
I don't know the exactly, but I think
Whatever it
during
is.
during transmission, I think digital signals somehow need a very huge bandwidth.
Right, Mehbooz. It's exactly right. Like whenever you are sending a just a second. Yes, Mehfooz Alam, it is exactly right. Like whenever we are using a digital signal, so as per the theory, digital signal required infinite bandwidth. Okay, and such infinite bandwidth we cannot afford in a limited bandwidth channel. That's why when we are using a digital signal as an information, if we will modulate them, then in modulating signal it is in an analog form, so it is required a limited band. Okay, so that under the limited bandwidth we can transmit the signal easily, and whatever the distortion and all stuff is not going to be occur in that. That's why due to this bandwidth problem, like a digital signal required the infinite bandwidth, but that we cannot afford. That's why the compulsory modulation technique we need to apply, which actually required a limited bandwidth. Okay, so this is a basic reason behind that, to choosing a modulation for the digital signal. Thank you, Mahfouz. Okay, for this answer. It's absolutely correct. Yes. So these are the stuff we have discussed, and you know that like there are a different modulation technique we have. So we are talking about the Ethernet, which is actually related to the physical level communication and depend upon the physical cable you are using, like coaxial, twisted pair, and fiber optic. Different modulation technique is applied. Okay, at the different kind of the type of the signal, like ASK, FSK, PSK. Okay, if there is a digital signal, then ASK, FSK, PSK is there. Like if you are having analog signal, okay, if you are having analog signal and if you want to modulate it, then we are using AM, FM, PM, and kind of this such type of the modulation technique we have. So after moving to that one, we have discussed in the last lecture, which is that's related to this modulation technique. You have given the answer, and majority of the student has sent me the file of that also. So first of all, thank you for that one. Now, is that PPT is visible to everyone? Somebody please reply me. Is this okay?
Yes, sir.
Yes, sir.
So in Ethernet, what we have revised that in Ethernet, which is a physical layer communication. So, or we can say there are physical cabling are there, okay, and related to the cable, different module, different type of the kind of the speed you can achieve. Okay, the different standard like fast Ethernet, standard Ethernet, gigabyte Ethernet. You can achieve the different type of the speed, and different cable is there, different line coding is there, block coding are there. Several kind of the variation are there as per the requirement, like whether you want to go with the very high speed, very high distance communication, or very high speed low kind of the lower distance of the communication. According to that, different kind of the cabling and Ethernet technology is used, but that all about a physical media we required, either a twisted pair, or we can say coaxial cable, or the fiber optic cable. Physical media which is required whenever we are having a Ethernet. Now there are two type of the communication that we have discussed: wired and wireless. Okay, so in wired and wireless, what we have, like wired communication we have discussed, which is done through the Ethernet. But now before going to the wireless communication, okay, first off we need to consider that in wireless you need to consider like that there are several kind of the end connection are there. We can say several devices are there that all simultaneously want to communicate with one particular center. Okay, so if you are having a physical cable, you can directly identify that whether the signal is coming or not, and how the traffic is going to be controlled, how bandwidth is going to be set. You can manage it in terms of the we can say in terms of the specific bandwidth multiplexing and all technique. But whenever we are having a wireless communication, so first we need to consider that if there are a traffic is going to be generated, or if there is a wireless communication is going to be generated, or we are developing the device of the wireless communication, how we can manage the different end device communications. Like if simultaneously all of them are start communicating, but how we can manage, how we can handle their data, how we can handle their query, okay, whatever, how we are allocating the resources to them, how we are allocating the band to them, what are the techniques for that, all is going to become under the multiple access technique. So we can say multiple access technique, which is a kind of the two kind of the block technique we have under the data link layer, which is multiple access resolution and data link control. So in multiple access resolution, whenever we are having a wireless communication, So how there are the different functions of that? There are different functions of there by using this three protocol, or basically three protocol is divided in a multiple access protocol. Like first is a random access protocol. Name itself says random access. It means whatever the protocol which is working on the random allocation. Okay. After that, there is a controlled access protocol. Controlled access is, it means whatever the channel we are allocating, they are having some control. Okay, there is some type of the algorithm is there through which resource is going to be allocated. Next is a channelization protocol. Channelization protocol, like we are dividing our band or we are dividing our resources by using a different kind of the parameter like frequency, time, or code division multiplexing. So we are taking a help of the different parameter of the kind of the signals, like whether it's a frequency or the time or combination of both of them, code division multiplexing. So by allocating the channel through this particular technique, like whether we are allocating the signal in terms of the frequency availability, whether we are giving the channel location respect to the time availability, or one specific combined code, or one specific code, or one chip is there, according to that the resource going to be allocated. So depend upon that, channelization protocol is going to be occur. So quick, we need to learn over this all this stuff, like what is a random access protocol, what is control access protocol, what is channelization protocol, and all stuff. But you need to keep in mind that there are a lots of messages coming simultaneously. Okay, but how you can control them? Okay, how you are giving the instruction to your different end station that now your turn to send the information, now this is your turn to send the information. This is our main kind of the motive over here. And if there are some random signal is generated, so how we are allocating the channel to all of them, that are the topic we are going to be discussing this stuff. So first it will start with the random access protocol. So random access protocol or contention method, no station superior to another and none is assigned to control over to another. Okay, no station permit or does not permit another station to stand. At each instant, station has data to send, uses a procedure defined by the protocol to make the decision or whether or not to send. Simple, we can say there are no, we can say control. Anybody can send the data anytime. Okay, and depend upon the different protocol is going to be applied, that signal will start the communication. Okay, so there are a specified there are a procedure is defined under this random access protocol at particular instant. According to that protocol or procedure, any station can send the data and any station can send their data. Okay, so this is a stuff over here. So it will starting with the Aloha and CSMA, channel carrier sense multiple access, then CSMA CD, CSMA CA. So there are a different protocol out there. So we need to discuss one by one. But one by one we will see, and you can get the idea that why this is called as a random access. So this is a simple frames allocation, or we can say frame transmission kind of the diagram in a pure Aloha. Now in pure Aloha, you can say that 4 station is sending their files randomly. Like if we can plot the time axis, so frame 1 and frame 2 is going to be send their data in any instant of time, as well as station 2 is also sending, station 3 also sending, station 4 also sending. You can identify that in overall time. If you can just picture the entire time duration, let's take there is a 10 second of the time, just for example. So in the 10 second of the time, 2 region is going to be identified from the pure Aloha. While 2 region is collision region and non-collision region. So what is a collision duration? Like we can say there are a single channel is there, which is connected with the 4 station. एक channel है वो 4 station के साथ connected है, और सभी के सभी चारों के 4 स्टेशन अपना डेटा भेज रहे हैं. All of them are sending the data simultaneously, but doesn't having any control. Like anybody can send the data at any time. Okay, if you can take a 10 seconds, so 10 second में कभी भी data भेज सकता है. So if such type of the scenario is there, one region is going to be created, which is a collision region. I mean, collision region, what we have, like all the frame or all the station frame or some of the station frame get collide. Like आप ये कह सकते हो कि like वो particular time duration में एक की जगह ज्यादा फ्रेम है वो पर्टिकुलर टाइम ड्यूरेशन में ट्रांसमिट हो रही है. You can take like the example, like let's say this is a 2 second, let's say there is a 2 to 4 second, let's for example. So during the 2 to 4 seconds, simultaneously all the stations are sending their frame. Okay, so at that time collision is going to be occur. Like in channel, that actually receiver cannot identify that which frame I need to take from station 1, from station 2, from station 3 or station 4. Simultaneously, I'm getting the frame from the all the stations. So that period considered as a collision period, collision duration. While collision free duration where only single station is sending the frame, like you can say in initial duration that only from the station 1 the frame is going to be transmitted, while at the end of the particular 10 second you can say only station 3 is sending the their frame. So we can say that particular duration considered as a collision less, or we can say collision free, where only single station is sending their data, while rest of the station is going to be silent during that time. Okay, so this thing is going to be happen if you are having a pure aloha, no control that who is going to send at which particular duration. So we can say there is a collision is going to be occur, and that collision duration is going to be vary. It is also not going to be fixed that at this particular distance collision occur, this particular duration it's going to be vary depend upon this station is sending their data. Okay, so in a pure aloha, this is a stuff is going to be happen. How? Like ये पूरा स्टेशन कैसे काम करता है? If you are following a pure aloha protocol to allocating the channel, how it is going to be proceed, or how the data is going to be transmitted. So it will start with the some of the stuff like waiting period, number of attempts, propagation time, back of time, transmission time, several stuff is there. You can you can understand this protocol like this one. Initially that timer is going to be 0. Let's take our attempt, number of attempts going to be 0. It start with the fresh one. Then it will send one frame. Okay. Then it will send one frame and it will wait for some time. Okay. Station है वो frame भेज देता है और थोड़ी देर तक wait करता है. Wait for acknowledgement. So whatever the frame I have sent in the channel, whether from the receiver side, whether I got the acknowledgement or not. If I get the acknowledgement, then it's a success. It means my frame has successfully transmitted. If it is not sent, if it is that acknowledgement not received and that particular wait period, which is a 2 multiplied by TP, then what I will do, I will increase my attempt by 1. So K is going to be K plus 1, and then it's going to be attempt by 1. Again, it will choose the random time. Okay, it will choose the any random time, and again, it will wait for that time which is equal to the R multiplied by TP. Now, what is the R we have? Like R, we can say that we can say particular random sequence number you have. So TP, which is a maximum propagation time, TFR, average transmission time. Likewise, it will wait for some time and again it will send the frame in your channel. तो क्या करता है? Acknowledgement नहीं मिला तो वो जो attempt है, number of attempt उसको increment by 1 करता है. बाद में फिर से थोड़ी देर बार वेट करता है और फिर से एक रैंडम पीरियड पे वो अपना फ्रेम भेजता है, सेम फ्रेम, एंड अगेन दिस प्रोसेस इज गोइंग टू बी रिपीट. और वो प्रोसेस कितनी बार तक रिपीट करता है? until and unless your maximum attempt not reach to the normal 15. ये 15 टाइम्स तक ये पूरा प्रोसेस होता है टू सेंड दी वन पर्टिकुलर फ्रेम. अगर उस ये 15 टाइम अटेम्प्ट करने तक अगर वो फ्रेम भेज दिया और एक्नॉलेजमेंट मिल गया, then it will go with the next frame, and the same process is going to be followed for the that particular frame. Okay, so this is going to be happen, like whether the acknowledgement is received or not. If received, then success, go with the next frame. If it is not, then do this looping sequence. Okay, now why, like what is the reason over here that why acknowledgement not received? Can anybody tell me? ऐसा क्या होता होगा कि acknowledgement नहीं मिलेगा? We have discussed one collision period over there. क्या होता होगा कि acknowledgement नहीं मिला और ये loop हमको चालू रखना पड़ेगा? Why is it so? Anybody please reply. Am I audible first of all or not?
Hello, sir.
Yes, बोलिए.
Sir, your screen was froze.
My screening was not visible. This PPT is already kind of shown in my screen. Is it not visible? Hello? It was freezed. It is visible. Let me just share my entire screen. I have shared one PPT. So have you got this diagram or not? First of all, there is diagram, procedure of pure Aloha. Have you got this or not? Can anybody tell me why this looping is required? Under the which condition this acknowledgement not going to be received? Acknowledgement कब नहीं मिलेगा? ऐसा क्या होता होगा pure Aloha में कि acknowledgement नहीं भेज सकता? Your receiver cannot send the acknowledgement. When? Anybody please reply.
સર આ ડાયાગ્રામ ફરીથી સમજાવજો ને આ ફ્રીઝ થઈ ગઈ હતી સ્ક્રીન તો ખબર
Okay.
નહોતી.
So have you got this diagram or not? First of all, this Aloha and this collision and all stuff.
સર ફર્સ્ટ ફ્રેમ થી જ હતી ઓલો ફર્સ્ટ ફ્રેમ આવે ને ત્યાંથી જ.
પહેલાથી જ ફ્રીઝ હતું અહીંથી જ.
હા
તો બોલો તો ખરા, હું 15 મિનિટ થી બોલું છું, કોઈ કહેતા નથી સાહેબ તમે શું બોલો છો, પીપીટી દેખાતી નથી યાર તમે. ઓકે ચાલો ફરીથી પાછું. So this is a multiple access, like in a multiple access that we are deciding for the wireless communication, where whenever we are having a wireless communication is there and there are a multiple stations are connected simultaneously. So whenever we are sending the data, it's obvious that there are traffic going to be created, collision going to be created, and we need to allocate the resources in such a manner that every station can send their data in one particular format or with one particular process or with one particular protocol. Okay, through that less number of collision is occur and maximum kind of the throughput is going to be created. So for that multiple access protocols are there, which is categorized under the three channels: random access, control access, and channelization protocol. Now random access, it means any station can transmit the data anytime. Okay, so that is a random type of this stuff, like randomly, like everybody can whenever they want to access, they can access the channel. Likewise the random access we can say. While control access, there are some controlling algorithm is there through which only or under that process only your channel or your station allowed to speak. Okay, rest of the time they need to silent. So there is a control access is there, so specific control is given to the station to speak. While in channelization protocol, it is a allocation of that entire bandwidth according to the multiplexing, like frequency division multiplexing, time division multiplexing, code division multiplexing. So there are a multiplexing technique is there which is applied to allocate the channel, okay, with a different station. So this is a channelization protocol. So we have started with the first, which is a random access. Now in random access, no station are superior to others. Anybody can send their data at any time, okay, whenever they will require. Under it there is a 4 category are there: Aloha, CSMA, CSMA CD, CSMA CA. Channel carrier sends multiple access, carrier sends multiple access with collision detection and collision avoidance. We have started with the first of pure Aloha. Now in Aloha what we have? 4 station, 4 station है हमारे पास. चारों के चारों स्टेशन अपना हिसाब से कभी भी डेटा भेज रहे हैं, फ्रेम भेज रहे हैं, तो 2 रीजन यहाँ पे जनरेट हो रहे हैं. कौन से रीजन? कोलिजन रीजन एंड नॉन कोलिजन रीजन. नाउ कोलिजन रीजन मतलब कि like whatever the frame that you are sending from all the station which is collide with each other, okay, during the one particular time period which is considered as a collision period. It means ये जो आप ग्रे रीजन यहाँ पे देख रहे हो, यहाँ पे चारों की चारों या फिर multiple station are sending simultaneously, that considers a collision region. But दूसरे frame है like frame 3.2, frame 1.1, so only station 3 are sending and rest of the station are not sending. It means this is a non-collision time. Over here also this is a non-collision time. Now according to that, how this entire Aloha work, for that this is a one flow chart is there. So how this flow chart is going to be work? Like initially it will started with the attempt number 1. Okay, it is starting with the resetting the attempt number. So वो क्या करेगा? स्टेशन फ्रेम भेजेगा. कोई भी एक स्टेशन आप कंसीडर कर लो, चारों में से कोई भी एक स्टेशन है, वो फ्रेम भेजना चालू किया. Now it is wait for some time. Now wait for the acknowledgement. तो acknowledgement अगर मिलता है, if the acknowledgement is going to be received, then frame successfully transfer. Simple. So that simple process is going to be happen. But अगर एक्नॉलेजमेंट नहीं मिलता है रिसीवर के साइड की, स्टेशन ने तो फ्रेम भेजा था लेकिन रिसीवर साइड से कोई एक्नॉलेजमेंट आया ही नहीं कि भाई आपका फ्रेम मुझे मिल गया है, अंडर दिस कंडीशन व्हाट इट विल डू, इट विल इंक्रीज द एटम बाय 1. k 0 था उसका क्या कर देंगे वो लोग, k equal to 1, so that your system will do the k increment by 1. Then it will wait for some particular time, it will choose one random number. Okay, जो भी random period है वो random period में से कोई भी एक period choose करेगा और again randomly it will send the data. Okay, और फिर से ये प्रोसेस चालू होगा कि भाई एक्नॉलेजमेंट मिला ये फ्रेम भेजने पे, नहीं मिला फिर से एक रैंडम नंबर चूज करो फिर से फ्रेम भेजो. ये प्रोसेस कितनी बार होता है, मैक्सिमम 15 टाइम्स. So if 15 time is going to be there, then it will, in that condition, if you are successfully send the message, then new frame is going to be transmitted. Otherwise, it will abort the mission. It means by multiple time मैं भेज रहा हूँ, attempt कर रहा हूँ, फिर भी ये frame acknowledgement आ ही नहीं रहा है receiver के side. So मैं ये क्या consider करूँगा? There are lots of traffic are there, and I'm unable to send the data, and it will abort the entire transmission. Now my question over here, under which condition acknowledgement is not received? ऐसा कौन सा टाइम होगा या कौन सा ऐसा प्रोसेस हुआ होगा अलोहा में कि आपको एक्नॉलेजमेंट ही नहीं मिलेगा स्टेशन से? Can anybody give me the answer of this question? I have stuck to this. Are you getting my point or not? Hello? Those who have not seen the previous PPT, are you getting my point or not? Now, please feedback. Give me a feedback.
Yes, sir.
So, can you tell me in under the which condition acknowledgement not received? Anybody from entire class? Under the which condition when the traffic is very high? Okay. So आप माइक ओपन करके बोलिए ना पार्थ, क्या यहाँ पे चैट बॉक्स में लिख रहे हैं, मुझे लगता है कोई नहीं जवाब दे रहा. Yes, when the traffic is high, or you can say whenever the collision is going to be occur. So if we can see the PPT, so whenever this collision going to be occur, so station receiving side, that station getting confused that simultaneously I am getting all the frames from all the stations, so whom I need to acknowledge. So at that time acknowledgement not received, and again this process going to be started. Okay, so this is a pure aloha, like nothing control, nothing is going to be there. And now there is a vulnerable time for the pure aloha. Like vulnerable time, it means whenever you can say, like आप ये सोचिए कि ये पूरा फ्रेम यहाँ से बिगिन होना चालू हुआ, पूरा फ्रेम भेजा, अभी एंड होने ही वाला था. Like one frame is about to end, but second frame is start beginning their communication. Okay. As well as after that, what happened? B has completed their kind of the transmission. Now A is sending their data, as well as A is about to end. A भी अपना फ्रेम पूरा भेजना कंप्लीट कर रहा था कि C चालू हो गया. Okay. So what is a vulnerable time which is equal to the starting from this one to this one? Now ये पूरा ड्यूरेशन में आप कोई भी फ्रेम इफेक्टिवली आप भेज ही नहीं पा रहे हो. नहीं A पूरा सक्सेसफुली मिला, नहीं B पूरा सक्सेसफुली मिला, या C भी नहीं. So we can say this is an entire vulnerable time duration which is equal to 2 equal to TFR, whatever that frame duration is there. That is going to be a vulnerable time in which like two collision is going to be occur. B is collide with the A as well as A is collide with the C. Okay. So to do that, to kind of the make it better, like ये हो रहा है, randomly signal भेज रहे हैं, so how we can modify this algorithm? So this is modified with the slotted aloha. Now what is a slotted aloha? Still it's a random access. It means randomly they can send their frame. It's not any sequence like यही sequence में भेजना है, यही time पे भेजना है, नहीं. It is a random, but under the random there are slots are there. Okay. So there are a specific slots of the time duration. Let's take 2 second का slot है, like 2 second, 2 second, 2 second, like that. So this is a 2 second slot we have, just for example. Like in that 2 second slots, any station can send their frame. Okay, it's not like randomly कि भाई कौन कोई भी टाइम पे भेज, आप एक बंदा 1 सेकंड पे, बाद में 5 सेकंड पे, बाद में 9 सेकंड, not like that. But there is a particular slot is there. In that slot randomly any station can send the data. So we can say, you can see there are a collision is going to be occur in these two slot, while there are a multiple station are sending their data simultaneously. Okay, so ये करने से क्या हुआ, like your whatever the collision duration is there, which is limited during that particular slot only, and in the rest of the time frame you can receive. Okay, so you can say collision is going to be occur under the specific slot, and rest of the time your successful frame you are receiving. So this is a kind of the frame, kind of the controlling mechanism is there whenever we are using a slotted allo. So how it is differ from pure and slotted? By applying a different slot period to this particular duration, you can actually kind of the limit your collision. Okay, this is the main advantages while moving from pure aloha to slotted aloha. Now slotted aloha may vulnerable time, now it's limited. Like whenever there is a slot period is there, that slot period only equal to the frame period, which is your vulnerable time, and rest of the time is going to be successful frame transmission time. Okay, so that vulnerable time is going to be reduced actually over here. Just a second. Okay, so this is a time. This is a stuff we have now. This is actually a diagram of space or time model for collision in CSMA. So we have started with the pure aloha, discussed with the slotted aloha. Now we need to discuss what is a channel sense multiple access.
ડોક્યુમેન્ટ પર લખવો પડશે ને ડોક્યુમેન્ટ અમારું ટોપિક છે કીવર્ડ છે અને એબ્સ્ટ્રેક્ટ છે.
Yes, so in a channel sense multiple access, just listen carefully. This is the last diagram that I'm going to do with this entire lecture. Now you can consider that there are 4 stations we have, A, B, C, D, and with respect to the time, okay, in a different time duration, that station will send their data randomly. Okay, it's not specific time, but simultaneously. Right now, let's consider that under the T1 condition, what it will start. Like B station will start their transmission. Okay, B is continuously starting their transmission, and rest of the station are silent right now. Okay, nobody has started the transmission till now. So you can say at the T1 time duration, B has started the transmission. Now at the T2 time, you can say at the T2 time, C has also started their transmission. Okay, now C has also started their transmission. Already B has already started their transmission. So we can say after some time, you can say A is at another place, B is at another place, C at another place, and D is another place. You can say there are a different distance are there between their different station. Okay, और सब लोग एक स्टेशन को अपना डेटा भेज रहे. Now consider कीजिए कि B ने already डेटा भेजना चालू कर दिया था. Now it is already sending their data. Now when actually that station, when this actually that signal is going to be collide with each other, you can say when it is going to be collide with each other, आप कह सकते हो like whatever the channel is there, now कोई एक channel के साथ B connected था, C connected था, D भी connected था, A भी connected था. B ने 1 second second number, let's say T1 equal to 1 second, 1 second पे उसने transmission करना चालू किया. Okay, at the second number 3, okay, at the third second T2 has already started. तो तो आप कह सकते हो up to the second 2, up to the distance between 1 second to 2 second, your channel is going to be free, and only B channel you can kind of the observe. Okay. After that, how you can say, like in an entire kind of the communication distance, what you can say, whenever the signal which is generating from the B, when it is reached to the C, okay, at that duration it will find out the collision. Okay, so what you can say, that whatever this gray region is there, gray region is created whenever your signal is going to be received to that station. आप कह सकते हो कि भाई मैं अभी अपना ट्रांसमिशन, मैं अभी सिग्नल बोल ही रहा हूं, ठीक है, आप भी अभी बोलना चालू करेंगे, तो वी कैन से दैट साइमल्टेनियसली आवर बोथ वॉइस इज गोइंग टू बी कोलाइड, and we can say it is creating a traffic and nobody and getting the idea that who is speaking and what I need to get. This is going to be happen like this one. Consider that you are situating at another place. Okay, तो आपका जो भी वर्ड और जो भी इंफॉर्मेशन है वो मुझ तक पहुंचने के लिए लेट्स टेक 1 सेकंड का टाइम मिला. Okay, so you can say for that 1 second you are only speaking, but when both of them, when simultaneously we both are start speaking, then the collision is going to be occur. So this is going to be happen that, like, if simultaneously station is going to be transmitting, and if you have found out that, like, I am already sending the data and you are giving me the data, so I can say the collision is going to be occur, and that gray region is going to be defined, okay, whenever such type of the collision is going to be occur. So you can say until the B will do their communication, okay, so B which is near to A, so so we can say A is getting that data kind of the in very kind of the short time. So you can say that B is getting the data to the A up to kind of the minimum time, but data which is reached to the C, it will take a time because the distance is larger. So we can say A will hear it early, while C is going to be hear the same information after some time. और जब तक ये डेटा यहाँ पे पहुंचा होगा, C ने already transmission चालू कर दिया, so we can say that collision is going to be occur on that particular duration. Similarly, it's going to be happen that D will hear the C very early. Why? Because it's near to them. But whatever the data generating from the C, which is send it to the B side, it will take some time. So we can say जब तक C का data B तक नहीं पहुंचता, तो तब तक it's considered as a B is sending the data. So we can say there are a yellow mark is there, which is showing that this is an entire time duration where B is sending the data, while this is a blue line, we can say area where B signal is going to be exist. Over here, A's signal is going to be exist, but while in the kind of the mid of the region where the both of the signal is going to be exist, and you can say this is a collision period we have in a CSMA, channel sense multiplexer. Like channel, it's sensing the channel. Like ये time duration पे B will sensing that right now the collision is going to be occur, or right now I'm getting the signal from the one station, right now I'm getting the signal from the another channel. Likewise, the channel is going to be sensing. Okay, so this is a main stuff that I want to convey over here, that what is going to be inside that sensing mechanism. Okay, like already I am sending some data and suddenly I'm getting the kind of the request for acknowledgement. So I can get the idea that I have already started before the 2 second. Okay, instead of getting the acknowledgement from the nearby side, I am getting the request for acknowledgement to give them. मैं ये कह सकता हूँ कि अभी मैंने ट्रांसमिशन चालू किया था, तो अभी मैं एक्नॉलेजमेंट की राह देख रहा हूँ कि भाई मुझे मैंने जो डेटा भेजा है उसका एक्नॉलेजमेंट दीजिए, लेकिन दूसरे स्टेशन अभी ये मुझे भेज रहे हैं कि नहीं हम फ्रेम भेज रहे हैं, आप एक्नॉलेजमेंट दीजिए. सो दिस इज गोइंग टू बी अ कोलिजन पीरियड इन जस्ट सिंपल एग्जांपल आई कैन से, or in simple word I can say this is a channel sense or that particular process is. So this is a timing diagram we have. So we will keep this stuff up to this particular point. Anybody having any doubt over here, then tell me first of all. Any doubt, like what is the stuff, how what are the things is going to be occur. In next lecture onwards, we are going to discuss that what are the different strategy are there. Okay, in a CSMA, what are the persistent technique are there, like one persistent, P persistent, N non-persistent. What are this technique? How this channel going to be sensed actually? What are their different protocol are there? What are their feedback? What are their flow diagram is there? And if we can compare those diagram, how this entire channel sense multiple access going to be work, that particular stuff we are going to discuss in the next lecture. So now you are having a 15 minute of time. So what everybody will do, they will write down their kind of the conclusion on that what we have discussed in this entire lecture, and what is a CS, what is the basic three classification we have discussed, pure aloha, slotted aloha, and CSMA. Okay, so whatever the stuff we have discussed, just try to conclude in a 10 to 15 line, and at the end you write your enrollment number, and then after you can wait for the next lecture. Everybody start writing, and if you have doubt, you can call me. You can give me the kind of the doubt if you have. If you have doubt, any question, please ask me. I'm available over here. And if you have not doubt, so write your conclusion that what we have learned in this entire lecture. And at the end, you write your enrollment number, and then you can leave. I hope you have got the unit test 3 paper, everyone, unit test 2 paper, sorry, and everybody has start working on that one. Make sure it will complete on that specific kind of the deadline. And I'm very happy to say that there are some of the student has already submitted their unit test 2 paper. Some of the students has already submitted. Okay, let me just start just to inform you that there are lots of students are there. One submission I have, one submission I have received. Okay. And who is that person? Let me just say their name. It's not directly, but it's not from our class. It's from TC3 class. So one of the students from TC3 class already submitted the take-home test paper. In just how many days? In just 4 days. So people are start submitting. So you should also kind of the make yourself kind of the flexible to submit all this stuff. Everyone start typing your answer. At the end, you write your enrollment number, and then you wait for the next lecture.